So we'll see first this Jamovi. About this introduction. Many of you have heard about it, that it's midway between the SPSS and R. Because in R, what we do, we have to write the commands, which is a tedious task for a medical professional, because we are not very smart in writing too many commands, and we don't have much time to write all those commands. Even if we copy paste it at one place, we find it a little difficult, and that initiative is less when we have to perform our data analysis. Whereas if you see the SPSS, it's menu driven. That means you have to click the option, and then the out.
Can you repeat,
voice
madam?
breaking. Okay, that's what we felt.
Thank you.
Okay, so is it okay? Am I audible now?
Yes, madam.
Yes, ma'am, you're audible.
Okay, thank you. So keep giving us the feedback regarding audio. If any problem is there at your end, maybe we will rectify. So this Jamovi, I will repeat it once again. So there are two R software where we have to write the commands. And there is another extreme, which is the SPSS, which is the menu.
Hello, ma'am. Your audio is not clear. Actually, it's
Okay,
breaking. And,
okay. Let me check.
Yeah. Thank you.
It is okay. So I'll start. So hello, can you hear me now without a voice break?
Yes, ma'am.
Yes, ma'am.
Okay. So I was telling you regarding this software Jamovi, and it's a very important software because it's the midway between a R and a SPSS. If we talk about R, which is the backbone of all the software, in R, if one of you have performed the analysis, you can recall that you have to write the commands. There are commands for every options and every test, and you have to write those commands. So it is a bit difficult and tedious for a medical personnel to write those commands. Even if you write it and save it at one place, every time you have to copy and paste it if you have to perform a analysis. So that's not very user friendly for a medical professional. Now there are another extreme when there's one person. So there is another extreme, which is the SPSS, which is a menu driven. So in menu driven, what we do, that we have to put that always that option is there of clicking the option. So in that case, it is, since that is the menu driven, so it is easy for us. But since SPSS is not a free software, and its cost, maybe all of us cannot afford it. It's basically the institute which buys the software, and in individual capacity, most of us don't feel like buying it. So this Jamovi is a free software, and it is a very user-friendly software. So you will see this is the midway between the SPSS and R. So this was released very recently in August 2018, and it was updated in March 2019. So what we can do in this Jamovi software, in this basically you can do all the functions. You can do the basic data analysis, which we were doing it in the SPSS or in any other software like SAS Strata. You can do the advanced analysis, but for that you need module installation, because for Jamovi there are various modules, and depending on your need you can keep on installing those modules. Then there is you can do the meta analysis also, which also needs installation, like survival analysis. So all those advanced analysis, once you need it, you can download it. But today's session is basically we are focusing on the basic data analysis, which we require for the thesis purpose, for the manuscript, for the very basic one. We are not going on touching the advanced data analysis options in Jamovi. So when we run analysis in Jamovi, so I hope all of you have done some sort of analysis. Even if you have not done it, like if you see the SPSS interface, there is an output and there is a data. So both these views appear separately. So you have to navigate one by one in the output, and then you have to see the data. While in this case, Jamovi, we will see that when we run an analysis, the result, it gets updated, and it is a very dynamic platform. That means once you change the command, that whole output will change. So you don't need to rerun the whole analysis. The second is it saves time in table formatting, because most of the output that is in the form of an APA style table. So many a time you can directly copy paste the table in the Word form, and you can write your interpretation. You don't need to make a separate table. And like we have discussed that this Jamovi, it is written the background in the background, that all the commands of R is functioning. So if we will see this, that if you click this syntax mode on, then it will show you the various type of codes also, which are written in the background. Although we don't need all those codes, but the people who are interested in coding and knowing the background codes which is working for that particular function, you can refer to that syntax. And it is also a very point and click interface of R. So for whom Jamovi is recommended? So Jamovi is recommended for all the beginners who are very apprehensive of data analysis and who are always seeking and going to a statistician, or maybe some person who knows data analysis well. So that we just want to allay that apprehension. We want to reduce that apprehension so that you can use it in a very friendly manner, and you can write your manuscript, or you can do your thesis as well, whatever research work you want to do. So the use trend, if you see this, so article, there are 7,710 results which have used this Jamovi as a platform. And installation, you have received the instructions that this 2.2.5 solid version, which you have to download it. So we will start the session understanding the concept of variable. So in the concept of variable, what do we measure? In any research topic, if we see, we measure something. I think this screen is taking some time. Let me refresh the screen at my end, because it is not showing up at your end. No, so this, in the concept of variable, what is a variable? So basically a variable is something which varies. And what do we measure whenever we do some analysis? We measure these variables. So this variable is basically anything which is liable to change or which is changeable, as for example weather, because it changes, that's why it is a variable. All our biological and biometric profile, like anthropometric measurement, our weight, height, maybe creatinine level, all these are liable to change, that's why we call them as a variable. So anything which is changeable or which is alterable, that is, we call it as a variable. And in any study we measure these variables. So it is basically a characteristics which varies from one person to another person, and through a sample we want to specify the population value. That's why we do a research, because that population parameter is not known. That's why we are doing a research. We measure the variable and then we see about the population projection. In this case, if this is a person, imagine this is a person. So this person has a uncountable number of variables, but we measure only those variables which are of our interest, like which is pertaining to our research question or in which we are interested in. So we don't measure all the variables which are there in one person. We measure only those variables which are needed to answer our research question. So in this case, like if this is a population of whole population of myocardial infarction. So imagine this as a whole population of MI cases. And from that, I have taken out few samples of MI cases. This MI cases, so let's, out of those sample, if I'm talking of a single patient, then if this patient has these variables, there will be age, there will be some age of this person, he or she will be of some gender, a particular race, there might be some history of cardiovascular disease present or absent, and there will be some value of serum cholesterol. So out of that population, I have taken out a sample. And if we talk about one person in that sample, so this we call it as a datum. So the singular of data is known as the datum, but generally we never work in a single person. That's why you don't hear this term datum quite often. We basically always hear this word data because we always talk of a group of people. So this plural of datum is the data. So maybe if we talk about the datum, if let's say it's a hypothetical situation, this person is a 45-year-old male of white race with a history of cardiovascular disease, and the value of serum cholesterol is 230. So this is the datum. Now, if we are measuring the variable of a sample, so let's say I have taken 10 samples out of that population, and this is called the data. So the final value which we obtain from the data, that is known as the statistics. So this whole sample will have a sample statistics for age, sample statistics for gender, for race, for cholesterol, etc. So whatever the data, the value of the variable of that whole sample, we call it as a sample statistics. Whereas if you talk about these variables in a population, we call it as a parameter. So remember, P is for P. So parameter is for population and S is for S. So sample statistics is for the sample. Now, if we are measuring the variables for everyone who is there in the population, so that we call it as a complete enumeration, which we don't do, because most of the time it is not possible to include everyone who is there in the population. So what we do basically, we take sample, like in this case, maybe 10,000 people we have taken out of this population. So, but this is a very huge number because there is a difference between 10,000 and 10. So this 10,000 we call it, and then we are measuring the population parameter. We are estimating the population parameter. We will see it in the description, then descriptive and inferential statistics also, that whenever we project the population parameter using the confidence interval, we call it as a population parameters, or we call it as a inferential statistics, because through that sample, you are estimating the population parameter, which is not known, which is unknown. So this could be like the population parameter of age, gender, race, cholesterol, etc. So for any variable like age, gender, or MI status, usually this sample statistics, it is never equal to the population parameter. There will always be some discrepancy between the two values. So that's why we call it that there is some uncertainty exists when we are performing a inferential statistics, because there are some sampling error by which we can never say that the sample statistics and population parameters are equal. So they both are never same. They both can only be same if you take all the individuals of a population, which is not possible. So this discrepancy of a sample statistics and population parameter, this is known as the sampling error. And the amount of this discrepancy decreases when you increase your sample size. So this issue we have discussed in the many webinars of the sample size estimation. Bigger the sample, lower is the discrepancy. And there is more validity of your result, which you are saying. That's how there is an importance of sample size. So now let's revise all this concept once again. A variable is something or some characteristics which is alterable and which is liable to change and which is different for different individual. A data is a measurement of observation which we take from a population, and a data set is the collection of those measurement or observation. Again, we call this datum or a singular person variable as a score also, and the numerical values which describes the population, it is known as the parameter, and the numerical value which describes a sample which we derive from a measurement of individual in the sample, that is known as the statistics. So statistics, what is statistics? You know, there is a branch known as the biostatistics. There is a statistics. So basically statistics is a scientific branch where we organize the data so that a meaningful information can be made out of that data. So that meaningful information, we make out both the objective as well as the subjective meaning, but we organize the data. So what is this observation? So basically this observation, whatever we measure, that is an observation. So we can measure like blood pressure, we can measure the, maybe in this case, you can see some emotional, through some emotional tool, we can measure the emotional quotient of the patient, we can measure the obesity, we can measure the weight of the baby, or we can measure the thyroid enlargement. So everything is a measurement. So by this measurement, what are we doing? Actually, in statistics or in any software, the analysis is performed basically in the quantitative, if we call about the quantitative data analysis, because there is a qualitative data analysis also where we talk of sentences and words. But when we talk about the quantitative data analysis, then all the data analysis is performed on numbers. That's why you will see that even with the text thing, we convert it into numbers, because without numbers, the software is not able to identify it and it is not able to perform all those operations. So we assign some number to this variable or measurement so that it gives some objective way, because text is always subjective. So by assigning a number, we give a number so that the software can recognize it. Like in this case, and basically our aim is of the measurement is to provide an accurate, objective and sensitive way so that there should not be any ambiguity in communication of our finding. So now there are basically 4 levels of measurement. So you can remember it by mnemonic NOI. N stands for nominal, O stands for ordinal, I stands for interval, and R is for ratio. I hope many of you know this, but still just for revision, we will quickly revise these concepts. So nominal is when the order of data doesn't matter. Like in this case, you can see male and female. So if you give 1 code to male and 2 to female, and if you reverse the code, 2 to female and 1 to male, it does not matter, because these number, this is not conveying something of any order. It is not saying that 2 is higher than 1. That means male is higher than female or female is higher than male. So in nominal, there is no order. We just assign a number to a particular category. The second one is the ordinal. When there is an order in the ranking, like when you measure a pain scale, you can see there is a mild, moderate, and severe. So definitely, if you are giving 3 to severe, so 3 is higher than the 2 and 2 is higher than the 1. In fact, 3 is higher than both 1 and 2. So there is a particular order. So that is like in the cancer staging. We stage the cancer like stage 1, stage 2, stage 3, and stage 4. So there is an order in this. We cannot give 1 to stage 4 because then the order will be reversed. That's why in ordinal scale, there will be an order, and that higher the ranking, more the order or the severity is. The third type of measurement is known as the interval scale. So this interval scale is a scale where we measure it into the quantitative variable, and the difference between the two time point will be equal. And the classical example is the time. Because if you take the time between the 10 to 11 a.m. and 8 to 9 p.m., it will show that these are two equal. So interval means the difference between the two time point will be the same. Talking about the fourth one, that is the ratio. Ratio means that it will have absolute zero. That means this, if you take the ratio of 0 to 20 and 0 to 40, it will give you some ratio, and that will be a valid ratio. Like in this case, can you tell the difference between the distance between these two measurements? So this is the 10 kg and this is the 5 kg. So if you see the difference, it is the 5 kg. If you see the timing, so this 10 a.m. and 5 a.m., what is the difference? This is 5 hours. So this is, now the difference is same in both the cases. But if you talk about the ratios, so can you tell in this case that 10 kg is twice the 5 kg? Please answer in the chat box. So I can see only 2, 3 answers. All of you, please type your responses in the chat box. Okay. So with the next question, can you tell that the 10 a.m. is twice 5 a.m.? No, you cannot say, because there is no arbitrary zero. You cannot say that there is a zero time and there is no reference, so that you cannot take out a ratio. And that's the difference between a ratio scale and an interval scale. In an interval scale, you can never tell a ratio because there is no absolute zero. Whereas in ratio scale, that's how its name is. Because there is an absolute zero, so you can say that there is a ratio between the two. So these are the 4 examples of the type of scale which we use. So the reference point is actual in the first case, that is the ratio, whereas it is arbitrary in the second case, which was the interval. So if you see the hierarchy between these measurements, so nominal is the weakest in the order, whereas the ratio is the strongest in the order. So now there is a concept of dependent and independent variable. So in dependent variable, what do you see in this picture? So in this, you can see that there are 3 flower vase and there are 3 water drops. And you can see that these are variable in sizes. So in this case, it is the different amount of water for all these 3 plants. And the amount we have shown it by the water droplets, the size of the water droplets. It is maximum in the middle one, followed by this first one, and then the smallest in this third one. Now in this case, what do you see in this picture? In this picture, you can see that there is a plant. In this case, this is not growing very well, and this is okay, but not as good as the first plant. So in this case, you can see that the size of the plants are different. The number of leaves in each plants are different, and status of plant is different. So in both the pictures, you have observed 2 things which were varying. You can vary the amount of water, and you can you can see the effect on the plant. So if you have to label the independent and dependent variable, what will you call in this case? What is dependent variable and what is independent variable? All of you, please type in the chat box. Yeah, I think Kamlakar Sarva, you have raised your hand. Do you want to ask something? Or you want to say something, or should I repeat the concept? Okay, sorry. It was my mistake. I thought you want to raise some query. Okay, that's okay. So amount of water is dependent, water is independent, and plant is dependent. Yes, you are right that in this case you can change the amount of water. So whatever you can change, that is the independent variable, and its effect on something, that is the dependent variable. So in this case, we can change the amount of water. So independent variable will be the amount of water, and dependent variable which is affected by this change, which can be the maybe the size of the plant, or the number of leaves, or the whether it is living or dead, how green it is. So all those things are the dependent variable. So although this concept is more important when you perform the regression, but still this concept of independent and dependent variable is important. So now there's another way, like we call it as a qualitative and quantitative data. So till now we have learned regarding the 4 scales of measurement. We know what is the nominal variable, what is ordinal, what is interval, what is ratio, what is the difference between the interval and ratio scale. Then we saw the concept of dependent and independent variable. And then now we are going towards the third classification, which we call it as a qualitative and quantitative. So basically the quantitative is whenever we measure the data in numbers, we call it as a quantitative. And whenever we measure the data in words, like we do in the qualitative, we call it as a qualitative. Although in case of this quantitative analysis, we do assign some numbers to the qualitative variables also. Like in this case, gender, maybe we do assign some nominal. So nominal variables are many a time when that order doesn't matter. It's basically the qualitative in nature. So this in this quantitative, you can have 2 types of variable like data. There is a discrete and there is a continuous. So whenever there is a gap between the possible value, we call it as a discrete data, like number of newborn in a hospital, maybe the number of children in a family, total number of students in a class. So all these will be the discrete one because it cannot have a fraction. So there are various, so that's how we call it as a gaps between the possible numbers is there. That means between 3 and 4, there is a gap. So all those values are there, but we cannot include them. The second is the continuous. So in continuous, there is no gap between the possible value. Like all the the blood measurement of the serum values which we take out, there is a fractional value. So it can have any possible number. So that is the continuous variable. So all hemodynamic variable, all the variable which we measure on an individual, that is a continuous variable. Like you can take age, weight, height, even age you can measure it in point fractions, although we take it in a whole number, but you can take it like maybe days and hours. In newborn cases, we take it in hours also. So it depends. So qualitative, like categorical data. So this qualitative is when we data characterizes it, but it doesn't measure the properties of a thing, and it is not numerical, but we assign a numerical value to it, like the socioeconomic status. So all these qualitative, we call it as a categorical data. There's a pain which we classify it as a mild, moderate, severe. Religion, we call it as a Hindu, Christian, Muslim. So although these data are qualitative in nature, we do assign a number to it so that the analysis can be performed. Improvement may be mild, moderate, or remarkable. So lastly, we classify data into quantitative and qualitative. Quantitative is basically the numerical value, and the qualitative is the categorical, where we assign numbers to label it as a category. And this quantitative is again divided into 2 types, discrete and continuous, and the qualitative is again ordered and unordered. And this is basically the scale. So in case of a qualitative, we measure the nominal and ordinal level of data. In case of a quantitative, we have the interval and ratio. So why there is so much importance of these qualitative and quantitative data? So they are important because they behave differently, and the choice of test which you have to perform, that depends whether your data is categorical or whether data is continuous in nature. So that's how it is very important to distinguish between a categorical data and a continuous data in Jamovi or in any software for that matter. So this is one of the example. You can see that it was, and then again you can categorize the data. You can convert a continuous variable into a categorical one. Like we always do this with age. So that's why it is recommended that you should never take age or any continuous variable. You should always take it in the continuous form, and later you can classify it as a categorical. Don't categorize it since beginning. So in this case, you can see this is a gender, which is the male and female. And you can see this is a nominal, again a categorical, religion, nominal and categorical. So all these are ordinal and nominal, which comes into the categorical. And then if you see this stress score and coping score, so this is a ratio scale, which is continuous nature, which is a continuous data. So this is regarding the type of variable. So now if we see the another, now we'll go to the basically the Jamovi. So before I go to the Jamovi, there is a very important concept of clean data entry. So till now, are you clear on the concepts which we have told to you? Or do you want something to be repeated? Any questions, any query up till this point? So we have covered that, like general Jamovi, its importance, how it is different from SPSS, although we will see it when we'll actually. So if there are no questions, then I'll go to the third one, that is the basic rules of data analysis. Data entry, sorry. So this deliberately we are taking this session because we have found out that before you learn the commands, it is very important to have a clean data, because most of the statistician and most of the people who are into data analysis, they say that 80% of the time it goes into the data cleaning and data mining, and it is only the 20% which goes into the analysis. So once you have a clean sheet of data, the analysis becomes very easy. And we are coming across many data sheet where you will find that people, they don't know how to enter data. Although we cover it in our research methodology foundation course, that's a very important step, how you should enter your data, or you have a file, how to clean the data. So this is just to show you some basic steps which you can perform, and what are the do's and don'ts of this data entry. That is very important. You should remember it by heart. And once you know this, the whole data entry process becomes very easy, and analysis is then the easiest task. So now you can see this, although we have shown this in the initial, okay, I'll maybe show this slide at the end. So now there is some analogy between doing an operative management and doing a data management. So a surgeon, if you think from a surgeon point of perspective, what he is supposed to do before he performs a surgery. So the patient needs to go for a pre-anesthetic checkup. So he should have a PSC approval. It may take hours or days, because there might be some parameter like which is deranged. Many times blood sugar is raised, hypertension is there, blood pressure is not controlled, or the TLC is high. So once the patient is ready with all the parameters within normal limit, then that PSC approval is not done. Then the patient goes to the operation theater, and there the OT, it might take from 1 hour to 10 hours, depending on the type of surgery and the skill of the surgeon and the complexity involved. And then the post-operative period also, it may continue for months or years till the patient becomes normal or completely cured. If you have the same analogy in data, this cleaning of data, it also takes many hours. It may take few days also to get this data fit for analysis. When this data is fit for analysis, then again it may take maybe 2 hours, 1 hour to 10 hours continuously, depending on the type of analysis or the complexities of the situation which is there. And then in the post-analysis period, till it continued till you publish the manuscript. And these days it is no, according to the guideline also, you have to keep that data saved for at least 3 years, 3 years and the 5 years also, depending on the situation. If it is not involving a medical legal, then generally 3 years. So that in research also you should have, you should save this data. So that post-analysis period also, that goes until you get your research published. So both these skills, whether you are doing a surgery, because that's also a skill, or you are doing this data analysis, that's also a skill. So they are very highly focused and they are very engaging and enjoyable also. The people who love to do this data analysis, they enjoy seeing data and they enjoy seeing the output and the graphs and charts when they see it. So it's a very enjoyable task once you are into it. The only difference is that it's a command, that undo and redo command, that is not there with the operation. Something wrong which you have done, you cannot really undo it. You can repair it, but there is no option of undo and redo command, which luckily we have in the data management. So there are two approaches which you can adopt when you have to enter the data. Either you can directly enter the data in Jamovi, or you can import it through Excel. So its recommended approach is you should enter your data either in the Google Sheet or in the Excel spreadsheet. We never recommend to enter the data directly in SPSS or in Jamovi software, because it is a quite tedious task, and in Excel this task is very easy, or a Google Sheet, whatever you adopt, both are equally good. So direct data entry in Jamovi, we will not tell you, although I will show you few things how you can do that, but still it is preferable that you enter your data in the this Excel sheet. So this direct approach I'll show you once we see that. So now first we'll explore this Jamovi. So this is the sample data set for the data set for entry. So you can see there are 5 patients, and once I'll open the Jamovi, I'll show you. So these are the variables and these are the categorical. You can see that these are the continuous variable and these are the categorical variable. So now let's see some basic rules of clean data entry. So now all of you please ponder on these slides for a few seconds, and then I'll ask following questions. So you can see this is we have taken a snip of an Excel sheet, and in here also you can see that there is a group A, there's a group B, then there's a combined 1, combined 2, combined 3, 4, and etc. So there are many sheets here. So this is one sheet. So in this case, can you find out something which is not looking right to you, or you are thinking that this should not have been done? Just to have more interaction from your side. Symptoms, presentation of symptoms and BP, clubbing of symptoms. Okay, yes, you are right. In this case, you can see that all these symptoms, there's a clubbing of symptoms. So if I need to make a table, I'm confused. What is this fever with chills, fever, headache, cough, etc. Again, this BP, this is 112 and 76. So this is making no meaning to me. And then name, that is okay, name, because we never publish name. It is just for your understanding purpose. But this is for group A. Now see this. This is group B. So again, the same thing you can see here. And you can see that there is a BMI which has been written here and with the question mark. Yes, Anuradha is right. BP systolic, diastolic in one cell, that is also wrong. In this case, you can see like if you have 2 groups, like in many people, you perform a comparative study. There is a one group and then there is a control group or the comparative group. So many times what do people do, that you enter the data in different sheet. you will enter the data for group A in one sheet and group B in another sheet. That we have seen many times. But this is one thing which you should avoid. You should have only one Excel for data entry. And in Jamovi, if you have multiple Excel, then it will not import. So it will import only one sheet and then your analysis is not complete. In SPSS, there is an option that you can select the type of Excel which you can import. But in Jamovi, if there are more than one sheet, it will not import the required one. It may import whatever is open, and once it has imported that sheet, it will not import the another one. So we will recommend to have only one Excel sheet of your data entry. Like if you have to do in the two group, so it should be in the same sheet, not in the different sheet. Now see this, even if the people who enter it in the same sheet, how do? They write group A and they write the next, serial number in the sheet. What is your comment on this? Is it an appropriate way? Incorrect way. Muhammad Sunita is saying no. Shruti is no need for group mention. Patil is also saying no. So in that case, where we should mention the group? There we need that group mentioning, because otherwise if I have to filter out the cases, or if you have to do the comparison between the group A and yes. So in Excel or in Jamovi, each column that represents a variable, and each row, if you talk of one row, it represents each datum or each individual, but each column represents a variable. So this group A and B should be in one column so that it is like a variable. So a person who is in group A and person who is in group B. Now I have done this. So you will see that many people, they first write A, and then they write B. So what is your stake in this? Should we write like this, first all group A and then group B, or can we write randomly? So in this case, it is not necessary that you will write A first and B. Yes, you can write randomly, and then you can use the option in Jamovi, in Excel, everywhere. So there is no need that all A should be written first and all B should be written last. No, it's not required. Just you have to give either A or B, and even if it is random, it doesn't make any difference for the analysis. So you are right in this case. So like this, maybe this is another data sheet where you can see there is a B, etc. So there is no particular order. It is random. So that's perfectly fine. So in this case, now what is your comment on this BMI? Should you calculate the BMI for each and every data and enter it, or there can be another way of doing it? Sunita and Shruti are writing no. Yes. So there is a option of this. You can use the formula in Jamovi. Also, this option of compute is there. So you can use the formula in Excel. You can use the formula, but we have seen many times people calculating it and entering, especially the PGs. The postgraduate students, they often do this mistake that they will calculate each and everything and then they will enter. So no, it's only the raw data which needs to be entered, and you can compute the variable. Now see this. Now what I have done, maybe I have written symptom 1, symptom 2 and symptom 3. So all those comments on symptoms which were appearing in the single row, I have separated it out. And this systolic and diastolic BP also I have separated it. So now is it okay? Can I say that this is a clean data? Okay, so few people are in favor and few people, they don't agree. Okay, so yes, I'll go with a few people who don't agree, because yes, this is a clean data where most of the variables are in the one column. You can see this group, you can see age and everything. But here, if you'll see the symptom, few person has written, because the person who is entering the data, he is not sure what is symptom 1, 2, and 3. So like few people, they will enter cough in this column. Now, if the person has said cough at number 2, he will enter this at number 2. And then maybe swelling at number 3. Many person can enter, if the person has said swelling in number 1, he will enter it here. So now how to do this? So in that case, you should write the symptom as a variable. So in this case, you can see all the probable symptoms you can write as a variable, like fever, cough, swelling, body ache, maybe all those major symptoms. And then others you can write which are very few in number. So that you can write because that will be not many in number. In this case, you can see, then you can write yes and no, and then you can make a table. So all those symptoms should be in one column. So if you have a data like this, where you have used the formula, you have calculated values, you have got all the continuous variable, all the categorical, because this problem is there with the categorical variable. So all the categorical variable in the one column with the specific name of the variable and then coding, then you have, this is the cleanest data entry. And if you have got such data sheet, then it doesn't take much time to analyze the data. So in this case, you can see this was one of the actual data which we had to clean it, because you can see here the address. So many a times if you take data from HIS, because this we have taken from the hospital information system. And that time, if you don't instruct the person how to enter the data, or you don't put your brain in making those variables, the data is like this. And I think it took around 1 month to clean the data, because the total number of patients were 33,000. And remember, if we have to make a spot map, like from where these people are coming. So see how it has been written. Gaya, Bihar, India. Patna, Jehanabad, Bihar, India. So all these three in one. Bhojpur, Bihar, India. So it was a very tedious task for us. So that's how, when we are designing a hospital information system or designing anything where it should be at the entry level, most of the research or most of the exercise should go that type, that what type of data. That's why many times you will see that we are duplicating our data. Already data is there, but when we are in need, we cannot use data. Text to column, it's not possible here, Venkatesh, because for that there should be same size of the difference or width between the two. And maybe because here if there are some commands, so that can be done, but we don't emphasize that text to column, because again that takes a lot of time. So it's better, we are recommending that you should have a separate column for each, like for district, for state, for country. And you will see these days, whenever you fill a form, you have separate column for each thing. Okay. So how to categorize fever later on? So maybe you can have two columns, fever with chills and only fever. And then you can have like fever with chills, yes or no, and then only fever, yes or no. That's the only thing which you can use. So any separate or anything which is special, because fever and chills is a special characteristics. So you can have it as a separate variable.
And suppose the person is having high fever and another person is having low fever.
In
So
that case,
later on,
it's the ordinal scale. So you can define it as an ordinal: no fever, low fever, moderate fever, and high fever. So in that fever, first you will have fever, yes and no. And then if those are yes, that's how you fill the form. And then for all those yes, you have that ordinal level of data. Okay.
thank you.
Yes, any other question?
No, ma'am, thank you.
Okay. So now this is again this thing you can see here, female, male, all those things are okay. But again, there was a problem with the address. So we should try whenever we are doing any research, whether it is a project, whether it is a thesis, although that time the data, number is less, maximum it is 150, 200. But when you are doing a big project, in that case, we put a lot of brain in the cleanest possible data entry, because then out of that you can make a dashboard. These days, people who will, I think many of you might be doing that ICMR projects where you take a huge data. And in that case, you are required to see that dashboard almost on the daily basis. In that case, unless and until you have a cleanest possible data, you cannot have a dashboard ready to see. So that's a very essential thing. And that's why we emphasize a lot on having a clean data entry. And that's not very difficult. You just have to, because when we are forming that sheet for the analysis, we don't exercise much. I mean, that we don't put our brain at work into at that time. So you should think from the perspective of output, that with this input, what will be the output. That's why that is important, this data entry. So this, like we have shown this at many places. This was one Excel sheet which we received about during the COVID time. So all these lab finding, you can see how that person has entered. And in this case, you cannot, even if you use the any amount of text to column or column to text, you cannot retrieve the data. In this case, you can see, and this was the actual data sheet which we received. Okay, and the number of patients, they were 400 in number. And you can think that how much time that person took in entering the data, and which was of no use. So in that case, it is always recommended that please kindly pay attention, those of you who are faculty, if you are getting a thesis done, please emphasize a lot on the how the person is entering the data. You can use any, like you can use, these days a lot of digital format is there by which you can take the data entry. So that you can do. So with this, I think now I will go to the Jamovi. These were the theoretical sessions. So let me see now. So I have covered this variable and this clean data, this navigation. So now we'll go to the descriptive statistics. So before that, I think, let me show you the few commands. So I'll open this Jamovi. So this, so can you see this, all of you? The screen,
Yes,
you can, I have opened a blank sheet here. Okay. So this you can see that we have talked regarding the Jamovi, that in the same view, you have a data view and you have a output view. So this is basically a MS Word Excel piece of MS Word format. And this is the data which we enter. So you can see here already there is a B and C column is there. So either you can enter a data. So we talked in the beginning that you can enter the data directly into the Jamovi also, which we don't recommend. But if you have to enter, like you can write here maybe the serial number. And then you can write maybe the like 1, 2, and 3. So you can keep on typing 1, 2, 3. Similarly, you can write here the second. Maybe if I want have to enter the systolic blood pressure, I may write here like 120, 130. Similarly, you can do a data entry here also. But we have asked you to do it in the Excel sheet and then we import it. So I'll just delete it and I'll show you how it works. So first, if you open this, you can see there are two interfaces. There is this output and there is this data. Here you can see there are many things. This is the variable. Already there are 3 variables which you can see, and there are options like edit, compute, transform, add, delete, and filter. In the data, you can see this is the data view. This is the button for the analysis. Driven and this command driven. And then there's an option of this edit. So now if you see this, there is a small button here. So if you press this like this analysis window, this will be the maximize. If you again press this window, this will be like the original one. If you want to have a full view of data, then you can press this data. And then if you press this button, this whole data view will be there. And if you again press this, then there will be output as well as data. So this is one button. And now can you see a 3 points here, 3 dots? So if you press this, you can see there is a syntax mode. If you make it visible, this on, then commands you can see in the output. That we will see. So now what I have to show you first, how to import a data in Jamovi. So for that, you can see here, first I'll delete this because we will be using. So now I'm doing the demonstration. So till now we were reading the basic theoretical part of the variables and about the clean data entry and about a little bit interface of the Jamovi, what is Jamovi and when it started and what is the importance. So now we are seeing the skill part. So I'll show you the demonstration, and after I think at probably at 3:30 we will be giving a breakout room where you will be performing these actions on your assignment file. So now I will show you how to import the data and how to perform some common commands. So this is a very important step because once you are done with these steps, then analysis becomes very easy. So for that, you can see there is a 3 lines horizontal line here. So I'll press this, and now you can see there is an option of open. Don't go with the option of import because then it leaves the first 3 columns as such. So go with this option of open. I have pressed this open, and now it leads you to you have to show a path. So I will browse this, and since this file is saved in this Jamovi day 1. So for this, I have to show this. This is the demo import levels compute transform. So I will click this, and the beauty of this Jamovi is it can import all data files. It is, you can see here type of files you can see. If you click down, it can have Jamovi file, CSV file, open document, Excel, even it can have this SPSS file, R file, Strata file, SAS, and all these things. So it can import all types of file. You don't need to specify because remember, those of you who have done SPSS, you need to select this Excel option from in the SPSS. Here you don't need to select anything. You just select the file and then press open. So once you have pressed this open, you can see that the data which is populated here. But since in this data, you can see only numbers now, and in the continuous variable, you can see that these are the like age, etc. But now the labeling of these variables is required. So now, do you get how we import the data? Go to these 3 horizontal line, click, go to open, then browse, show the path, select this and press open. I'm not doing it again because then again it will open it. Already the data is open. That's why I'm not doing it. So we have done this. Now the data is here. Now you need to give the label to that codes. So maybe you have these codes, like maybe 1 is for male and 2 is for female. So it can be done either by double clicking this thing. So if I double click this gender, you will see that there is a labeling of this variable has appeared. Okay. Or it can be done if there is, you can see there is an arrow here. So if you click this arrow, this view will be hidden. So it will be like this. Or you can go to the data, this variable, and you can use this option of edit. So if you use this option of edit, then also you can see the same thing which is here, which you have seen by double clicking that. So I'll go again to this. I'll go to the data. In this data, I will double click this. So once you double click this, you can see this variable. So already you can select the type of variable from this. So that's why the knowledge of this nominal, ordinal, and scale variable, because they combine all the software, they combine the interval and ratio together as scale variable. So this is in the form of a like continuous nominal variable. So I have selected the nominal. Now data type. So data type, there are various options here. You can see there is a decimal, there is an integer, and there is a text. So in this case, this is an integer because gender cannot be in decimal. So I have selected integer from this case. So if you select, like in this case, never select text. If you select text by mistake, it will not perform the analysis, because analysis is always performed in numbers. Remember in the SPSS, when we were clicking on the variables, that numeric, it was always in numeric form. So similarly, select integer. And then you can write here, these are the levels, but it doesn't know what is 1 and what is 2. So you can write here maybe male for 1, depending upon your coding, and 2 for female. And you can see this 1 and 2, it has now shifted towards the right side. And then you can, so now you can see that gender with this 1 and 2, it is now converted into male and female. So this age is okay now for all categorical variable, but you have to check each and every variable regarding its type once you have imported it, because many a time when you import it from Excel, there might be some changes in Jamovi. So once you start with your actual data analysis, please check all the variables regarding its type and whether it is the measurement type or data type. So if you come with this icon, you can move forward. So now my icon, this has come to age. So you can see here that it is a continuous variable, and definitely it is an integer because I have not measured it in the fraction. And the levels, there won't be any levels because it is a continuous variable. Again, I will press this arrow. So it will move from age to SES, socioeconomic status. So now again, this has moved. You can see here that this is again a nominal. If you wish, you can change it to ordinal, because maybe this 1 is for low, 2 is for middle, and 3 is for high. And in the description, you can write here, this is regarding the socio-economic status, because I have used a short form. So you can write socio-economic status. And then it is an integer. So 1, maybe I can write it as a 1 is for lower, 2 is for middle, and 3 is for higher. So now you can see this SES changing to this higher, middle, and lower. Again, you can go ahead, check this diabetes. This is again status. So you can write 0 for absence of diabetes, and 1 is for present, diabetes present, or yes, no, depending on what is your. And again, this is a nominal integer. You can go ahead. Again, you can write hypertension, maybe 0, no, have a uniformity, and 1 as yes. And then you can again go, you can check, these will always be in integer. Similarly, you can keep changing these variables. So I'm not showing you on all the variables. Now let's, this stroke will be also like 0 will be no and 1 will be yes. COPD will be like 0 and 1, no and yes. This admitted versus not admitted. So this is the status of the person at the time of admission. So maybe 1 is for the maybe sick, or maybe 1 is for the, this is like 1 is for the maybe ward, and 2 is for the ICU. So this is there, and I have changed, this is again integer, so I have changed it. Then again, so this is the end. So in this case, you can see that we have labeled all the variables. And in this case, if the variable is continuous in nature, although no variable is in continuous, like if there is a creatinine or some, you will see ferritin, in that case, you change this integer to decimal, because then you remember we read about the discrete and you read about the continuous. So in this case, this discrete is for integer and this decimal is for the continuous. So this is till now. So have you understood how we will do this? You have imported the data and you have labeled your data this way, using either the setup or double clicking the variable. This window will open. So if you have understood this, then I will show you the other functions, like how to do this computation of the variable. So are you people with me up till this point, or should I repeat anything?
Actually, ma'am, the data that we have imported, that might have been entered in the form of 1 and 2 only.
Yes.
Okay.
So
But
if you
now,
enter it generally in Excel, like, do you enter it in the form of words like numbers or text?
no. Like normally we enter like it's clean, but like for example, for diabetes, we would write yes, Y, N, something like that. But this data
But
that we,
in that case, again, that why you need to put that, there should be number behind it.
even in
Then when you import the data here, if
Hmm.
you go to the edit option, then you should put that Y for 1 and no for 2 or
before
something like that.
importing.
You're coding that word, and you have to change this into the integer. We will see this when we will perform the analysis. If you don't change this to integer now, then this will not take. Like if by mistake, like what I did in one of, I was analyzing one person data, and by mistake the text was there here, that the option was of text, and then when I performed the descriptive, no mean, no standard deviation, nothing was coming. So I was surprised, what is this happening, why this is not coming although the values are there, because the data type by mistake it was text. So until and unless it is number, it is not going to analyze it.
So before importing in Excel, all these words have
Yeah, I know. No, even if you have imported it through Excel, you check it here once in Jamovi. Otherwise, this will create problem when you go to the actual data analysis. So check each and variable its type, because many times even if you have entered it in Excel, while importation there might be some error, although it happens, not happens very regularly, but still, as a I think before you start, because and then you have to, again you have to do it when some command will go that there is error or you are not getting something, you need to go back to this section and check what is the problem.
okay, ma'am.
So anyone, any other problem?
Hello, ma'am.
Yeah, Anuradha.
Ma'am, the similar query as she asked her, if the data is in the text, can we change the into the numericals in the Jamovi, like in the label in this section?
Normally we in Excel also we enter that you should enter the data in codes.
Okay.
So then, because there is a way in doing the data analysis in Excel also. So that's how when you form the questionnaire, remember we always ask you to do a coding of that thing.
Yes, yes,
So
yes.
because when you enter it, definitely in Excel in the background, that from the drop down menu, you select male, female in yes and number. But although the text to number conversion, that is possible, but you should try entering it in number, and you should have the codes with you so that you can specify and you can give the label here.
Okay, ma'am. Thank you.
Is it any other query? Okay, if not, then I'll show you now next function, which is the computation of variable. So we did learn regarding the computation of BMI, so which you can do, but here for example purpose, I'll show you the computation. So I'll just close this. So in this case, the question which is there with me, I have to compute the total number of comorbidities. So you can see here the comorbidities. Which are the comorbidities? This is basically, it is starting from this diabetes mellitus. So if I am like before I go into the analysis, maybe the data sheet which we are using for demonstration purpose or for assignment purpose, this was the COVID data, which was a secondary data. We took these data from the case sheets and HIS, and then we did some changes, because that data was very, it was, we cannot say that it was normal. Many data was highly skewed, many data was normal. So we did some minor changes to make it as a real data of patients. So approximately 1600 data was there, out of which we took 180 data for the demonstration purpose. So in that case, like if you have to specify that number of people with comorbidities, so now I have to, so in that case, go to this, and wherever you keep this cursor and you compute, this appears after that. So maybe I want to keep this before this admitted. So I want to delete this variable. So I will write delete this column. Okay. And then press this. Again, I'll go to this CKD because this variable gets added later on. So I have pressed this compute. So this computed variable is the total number of morbidities a person has. So I will write maybe the variable name as total morbidity. And in the description, I may write total number of morbidity a person has. And then you can write here that formula. So in this case, the total number, I have to use the sum. So in this case, once you, there is an option, this is the function. If you click this function, there is a drop down menu. Can you see here? So this shows the formula. So it gives you two views. There is a functions, mathematical and statistical function, and then there are variables. So if you see this drop down menu, you can see there is an exponent, log 10. If you go down, there are statistical, this thing like all these options are there. If you go down again, you can see mean, rank, rounding off, scale, standard deviation, sum. So I have to use this option of sum. So I'll double click this. So once you have double clicked this, now you need to select. So in this case, I will start selecting diabetes mellitus. So click this. Okay, so I am just deleting this. So maybe I was showing you regarding this function. So if you see this fx option and there is a small arrow just adjacent to it. If you click this arrow, there is an appearance of these functions and the variables. So I'm using the option of sum. So sum you can see here. Here is the option of sum. So double click this. So once you have double clicked this sum with this bracket appears. Now you need to enter the variables. So I need to calculate the total number of morbidities, comorbidities a person has. So I'll start with diabetes mellitus. So you double click this and then you separate these variable with the comma. Again, select hypertension, then comma, cardiovascular disease, comma, then stroke, again comma, maybe COPD, comma, and CKD. And then press enter. So if you press enter, you can see here the total number of morbidities. Then I will just hide this and I will show you the data because this is the data. So let's see this. This is the total number. You can see it is ranging from 0, 4, 5, 6, 2. So this is the total morbidities and I have used the function of sum to compute this. Okay. So did you understand how to use that? If you have to go to this compute, then this function, and then all these options. So like you have to take the mean also. Mean, like you have got systolic blood pressure 1, 2, 3. You can use this option of mean here in this case. This is like mean. Again, it will appear in the bracket and you have to separate it by comma. So this is the way you have to do that computation. So now once you have done the computation, now maybe if I have to transform the variable. So like in the case of age, you always have to make an age category. So how to make that age category? So for that also what you do, you go to this compute option. And in this compute option, like you want to make a age category. So age is like maybe if I want to make like 30 less than, I am having 3 categories here, less than 30, 30 to 60 and more than 60. So how to do that? So this is the age cat. You can write age. In this case, you may write the full form of the variables also with the space because in SPSS, you cannot have a space when you are defining a variable. But here you can have. So you can write here age category of individual. And in this case, again, if you have to use the function command if, so go to this functions and use this command of logical command of if. So if you have used this if, now you start using, because now I have to give the command. So if I will write age, so if age is less than 30, I am assigning it 1. So give comma and write 1 and then again comma. So by this, what this system is meaning, that if the age is less than 30, I have given it as code 1. And then again give comma and end it again by comma. But again, I have to give us another command because I have to make 3 category. So again, I will select this if, and again, I will select this age. And in this case, you have to write age more than or equal to 30. And again, you have to select age and less than equal to 60. If this will be there, I will give it as 2 and then again comma. So before 2 there is a comma and after 2 there is a comma. And then again I have to write the third this thing if. Like if it is more than 60. So if it is more than 60, then again comma, I am giving it as third. But after that last one, you don't need to give a comma. And then you can see there is appearance of 3 brackets because you have performed 3 functions. And then you press enter. So something has gone wrong. Now I need to
Ma'am,
check.
age before 60, ma'am. Ma'am, age is not
Oh, yes,
mentioned
yes,
before
yes,
60.
yes, you are right. So here what I did, I should have written age. This I missed. So now you can see, so there can be some error. Just go and revisit your formula once again. Like there was an error from my side and that's why it was not taking it. So you can see now the age category and you can check also. In this case, you can check with the any subject. So this is 16. You can see the age of the person is 38. So it should be in the category 2. So if you go and see, this is in the category. Just a sec, it is coming ahead. Yes. It is in the category 2, age category. So this is how we compute the variable from the existing one. Now you have to go back to this, like we, in this case, you go to this, and again this category, you have to, when you will give that analysis, maybe that will come, but you have to remember it because that labeling option is not coming with this setup. Because because it is a computed variable. So maybe that labeling option, which was there in the SPSS, that is not coming here. So that is there with the computation. Now there is another this thing, like if I have to classify it like people who have got no comorbidities, 1 to 2 comorbidities, and more than 2 comorbidities. So for that also you have to go to the compute. Maybe you can write comorbidity category. In this case, again, you should use a function of if. So I'll go and select this if. So in this case, what variable should I select? You people can guide me.
Total morbidity.
Total morbidity. So I'll select this total morbidity. And then I'll say the total morbidity is 0. So for equal to, this is double equal it takes. So I may write double equal to 0, then it is maybe 0, like no morbidity. That's the code I have given. And then again, comma. Then again, I'll go to this if. I may write it as total morbidity. And again, if it is, number is 1 to 2. So equal to, it should be more than or equal to 1, less than or equal to 2. And in this case, I can give this command as 1. Then again, separated with comma. And then again, use this logical function if, again, total morbidity, and if it is more than 2. Then I may call it as 2. And then again, I will press enter. Now again, it is saying that this formula is misspecified. So in this case, maybe I can see here that I did some error. Maybe this equal to, less than and equal to, that is okay.
Ma'am, 1 comma will come after 2 last 2.
Yeah, 1 comma, no, after 2.
Last 2 मैम, last 2 के बाद में.
नहीं, last 2 के बाद there should not be any comma. There is one space here. Let me check. What did I write?
Hello ma'am, 2 equals to 0.
Equals 2 equals before 0. 2 equals to before 0.
No, in that
Double
case,
equal to 0.
Ma'am,
It is
last
already-
comma has spaces.
Ma'am,
Last three
total
comma has
morbidity
spaces.
before or less than and equal to 2.
before less than and equal to this one.
Ma'am, last 3 comma has more spaces.
No, why? No, this is not happening. There is some. This and there is a space.
First 0.
So this is not happening. Then maybe in that case, let me do it once again. Yes. I got it. What I did, this and, yes, and here also. So this is total morbidity. I need to write it here once again. So what I'll do, I'll go here and I'll select it once again. So now it has, so see, when you are giving this command, what I missed here, that this less than and equal to, whenever you give this less than and equal to and more than and equal to, this total morbidity, it should have that word of that particular variable in place. Otherwise, it will not come. Okay. So did you notice where I was doing that error? I missed that total morbidity when I was classifying it in the previous one also. Yes, Venkatesh?
Ma'am, I just have a query, ma'am. So
Yeah.
while we are doing this formula, if formula in Jamovi, it is not giving us a visual cue about what we are entering. For example, if we are doing the same if for command in Excel, it will automatically show after typing if and bracket, it will highlight the word logical test and then it will highlight the word value if true, so that we will be knowing what we are entering exactly. So this Jamovi is not.
No, it doesn't have this. We have gone through the entire module and it
Okay.
says that the commands are like this only. So you have to, maybe that doesn't, like in the Excel, you know na, that what is turning blue or that color is changing or the red, it is changing you, suggesting whether you are doing correctly or incorrectly. But this is the limitation, it doesn't tell you. So it will
why
show
don't-
only at the end. And maybe
Okay,
then
why
you
don't we
need to look.
Why don't we do it in the these very basic calculations? Why don't we do it in the Excel and then import it to the Jamovi?
When we will show the data analysis in Excel, then we will show that in Excel. Right now, this session is on Jamovi. That's why we are showing it in Jamovi. The people who know it in Excel, you can do it in, see the people who know it in everything. There are people who know it in SPSS. You can do it in SPSS, you can then import it. You can do it in Excel and then import it. But you should know, because since we are exploring Jamovi, so once you know each and everything in each and every software, then you can decide which one is easy for you. Okay. There are people maybe who are not very familiar with the Excel, then you might not be using that. So if you are very well, because there are many statistical analysis for which Excel is more than sufficient, right? But there is a problem of diagram. There is a many problems there. So just to shorten that, we have now explored this. So yes, if you find a particular function easy in Excel or in SPSS, you can do it there and then you can import the sheet, because these are the basic functions and these are maybe the one level, again, one higher level of data entry, clean data entry, where you have code, recode, computed everything, and now it's ready for analysis. Okay, so it's up to you. Maybe you can do all the functions in Excel and then import it. You can do all the functions in SPSS and then import it, or you can learn it here also. There's no problem. Since you are seeing it for the first time, it is appearing a little clumsy to you. But once you will do it many times, like you have been doing Excel for so many days, so many years, so that's why everything looks very simple to you. So similarly, if you do this, it will also look simple, I'm sure. Okay. So now once you have learned this, then we will go to the breakout room, because there is an assignment. So before we go to the breakout room, I'll again demonstrate the steps to import the data. These are the, okay, I forgot to communicate one thing, that okay, I'll show that in the maybe statistical analysis, because we have not gone into the statistical analysis yet. So you have to click this, then you have to click this button, open, browse, show it a path, and then import it. If you have to label the variable, double click the variable. You can do it double clicking this, then this will appear. You select the measurement type and data type, and then you label these levels like 0 and 1. Similarly, you can these are the two buttons by which this you can hide. And again, once you double click this, this will appear. And by this, you can move forward or you can move backward in the variables. So this is how we have done it. Now there is an option of compute, and we have seen how to use the compute. You can write the name of the computed variable and you can write the description. And this, once you click this small, this function, you can have all these functions. These were there in the SPSS also. Here there are many options. You can use log, you can use log transformation. There's a, you can see there is an option of Z score also. Then there is an option of this if, which we have used, if command, which is a logical command for transforming, for this computation and transformation of variable. So yes, we were trying one more option of to simplify this, which we did right now. Even without using and, we can perform this. So we tried, like, let's see this once again. This categorization thing. So let's, like, if I have to compute, again, I'll go and compute this. Double click this. Now you can see maybe this is the age cat. So age cat new, because I am creating a new one. So here what you can do here, again using the same function if. So can you all see on the screen? Because we are just telling what you have learned now. So this if option, and then you can write here like age. So like if I'm making age category, maybe 5 categories. So less than 20. So I may write less than equal to 20. And I have given this like code 1. So I will copy all these commands and then I may paste it, because that will save my time. I did not explore this initially, but then we thought that we can do it. So this again, 1, if age is, again you can write here, instead of less than 20, if you write here less than 30, automatically it takes this lower boundary as 20. So then there is no need to write and in between. And then you can change this 1 to 2. Then again, copy paste the same which you have. Again, I have pasted it. I may write it here like less than equal to 40 because I have written here 30. So this less than 40 means it is 30 to 40. So this will be your 3 because I have written 2 here. And this again, I will write age less than equal to maybe 50. So I did this and then 1. This I will change this 1 to 4. And then we can again paste it once again, depending on the number of categories which you want, maybe more than 50. So I may change this to more than 50. And then this I will change this to 5. This I will make this more than, because then all more than 50 I am taking it as category 5. And then you need to add bracket, number of brackets, because if you select this logical function from if, then automatically this bracket gets added. But since I have copy pasted it, so I have performed this command 4 times, so I'll add 4 brackets. And then press OK. So one more, sorry. So now you can see here, this has appeared, this category. And if you want to check it, whether it has performed, so you can take any values like 22. You can see its age. So this person has a 58 years. So it should come in category 5. So you can see it is in category 5. So this is how, even if you don't use the AND option and you can copy paste it, you can use this.